Right, let's go meet Jane. She said she'd be outside Madame Tussauds.
What's she like?
Tall, about my height, 40-ish, dark hair. Think you recognise her?
Yeah.
With a description like that, finding Jane should be easy enough. But is it? She could be Jane, and so could many other people in the queue, since lots of people fit that description. Like her. And her. 3 possible Janes. Trying to find someone from a description of what they look like isn't as easy as it seems. How much harder is it if you don't know what they look like? If that burglary had happened 100 years ago, how might the police have traced the burglar? Well, on the table they've got some clues, like the glass that the burglar handled. They've also got a big collection of cards giving details of known criminals, with their name, description and photograph on the front, and fingerprints on the back. Fingerprints are a great way of identifying a particular person, since no 2 people have the same set. If they search through these cards, the hopes are that somewhere amongst them there's a set of prints that match those on the glass. It was a long and often hopeless task. By 1900, this man, Sir Edward Henry, had found a way of making the task easier. He published a book suggesting how fingerprints could be classified or sorted into groups. Sir Edward noticed that in the skin of every fingertip there's a particular type of pattern, and he gave each of these patterns names. You could try making prints of your own fingertips and naming the patterns on each of your fingers. The most common pattern is this. Sir Edward called it a whorl. The other patterns you might find are loops, arches, tented arches, and composites. But what about the burglar's fingerprints on the glass? First, the fingers on the right hand. Whorl, 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 loop. And the fingers on the left hand, also whorl, 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 loop. Finally, there are the 2 thumbprints. They were on the other side of the glass. A whorl on the left thumb and a whorl on the right. Sir Edward gave each pattern a number according to which finger it was on. You next count the ridges between the centre and edge of each pattern. You can now build up a code which identifies the burglar's fingerprints. The fingerprints are classified according to their code. The job of finding a match is now much easier. The first part of the code gives a small group of suspects. The rest of the code gives the one match you're looking for. Ah, this looks right. Quick check to see the prints match. And there he is, a likely-looking subject. What other clues did the burglar leave? Well, there's his blood. Blood is full of many things, mainly round-shaped red blood cells with some spiky white cells. Everyone's blood is different, as doctors found out when they first tried taking blood from one person and giving it to another. Blood from different people couldn't be guaranteed to mix together. A puzzle for scientists was how to sort blood into types that would mix and those that wouldn't. In the early 1900s, a scientist called Karl Landsteiner solved that puzzle. He first took blood from a volunteer and left it to settle overnight. It divided into two parts. On the top, there's a clear liquid called serum. Underneath, the red blood cells. He drew off the serum and put it in another test tube. He then put 3 separate drops of the serum on a plate. To the first drop, he added the red blood cells from the same person. To the second, red blood cells from a different person. And to the third, red blood cells from yet another person. The first and third drops seemed to mix all right, but the middle drop is going lumpy. Landsteiner tried mixing red blood cells and serum from 10 volunteers. Sometimes the 2 parts mixed all right, those are the red blobs, and sometimes they didn't, those are the spaces. See any patterns? Blood from these people all reacted in the same way. They're called Group O. These 3 people also have similar blood. Theirs is Group A. These people are less common. They're in Group B. And people in this group are quite rare indeed. They're ABs. Classifying blood meant that forensic scientists can classify the blood found at the scene of the crime.
So would you say he had a round face or a...
Let's imagine our burglary happened in the present day.
Big, round face.
The woman saw the burglar and is giving the police artist a description.
The eyes, could you see the sockets?
Not really, they've quite deep set eyes.
So do you
It
think
looks
that's
easy,
about right?
but it's actually very difficult to give a good description of someone you've only seen very briefly. There's another way which can be easier. Photo fit. The idea behind photo fit is that a face can be stripped down and then classified into 5 basic parts: hairline, eyes, nose, mouth, and jawline. A face can then be reassembled from those parts. By varying the parts, you can make up almost any type of face.
I think that's about the closest to it.
The witness is trying to assemble the type of face that resembles the burglar.
I think that one. It's that one, I think. I think that one.
It would be helpful if you half closed your eyes so that the lines merge a little bit. Looks a little bit more like a photograph, like this. And with your help, we're going to try and alter some of the features to get it looking a little closer to the guy you're describing. Now, if 10 out of 10 were a photograph of the man we're trying to find, how many marks out of 10 would you give me for that impression?
8.
Good.
Is it a good fit? Let's run the burglar sequence again and see how well they did. Not bad. So, classifying faces gave us his photo fit. Classifying blood gave us his blood type. Classifying fingerprints helped us find his criminal record card. Classification is a basic part of science. It's elementary, my dear Watson.